Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 2.9 from the C programming language textbook by Kernighan and Ritchie. Now, exercise 2.9 says to explain why in 2's complement number system, x ANDed with x minus 1 deletes the rightmost bit. Use this observation to write a faster version of bitcount. Now, here's the bitcount function. I've just copied it out from the book, and here are a couple lines in the main function just to test bitcount. Now, we know, with basic arithmetic that this expression is valid. That is, x is the same thing as x minus 1 plus 1. 10 is the same thing as 10 minus 1 plus 1. And here I've given x minus 1 just some random binary value. And using this, we know that if I take this value and I add 1 to it in the binary system, I should get x back. Now I'm going to do this, I'm going to evaluate this, and I'm going to try and notice if there's anything nice or some subtleties in x. So let's do that. Now 1 plus 1, that's 2, but 2 in binary is 0, 1. So we should drop the 0 and carry the 1 into the next column. Then 1 plus 1 is also 2, but 2 in binary is 1, 0. And so we do the same thing. We drop the 0 and we carry the 1. Then 1 plus 1 is again 2, which is 1, 0. Drop the 0, carry the 1 to the next column. Now we have 1 plus 0. 1 plus 0 is 1. And there's no carry. And so the rest of these bits will just drop down. They will follow. Okay, so that's x. Now notice one thing here. The rightmost 0 in x minus 1 will turn into the rightmost 1 in x. Now this is very useful. Let's see why. So if I take x, and if I take y, or x minus 1, sorry, not y. Okay. And I AND them. What am I going to get? Well, 0 ANDed with 1 is 0. 0 ANDed with 1 is again 0. 0 ANDed with 1 is 0. Then here, the rightmost 1 in x corresponds to the rightmost 0 in x minus 1. And so the rightmost 1 in x is going to give me a result of 0 as well. And then here, everything else will stay the same. Because, x ANDed with x is whatever x is. So everything else will just drop down. So 0, 1, 0, 0, 1, 1, 1. You can evaluate that just to make sure, but everything else will drop down. And notice one thing. The rightmost the rightmost 1 in x, because it corresponds to the rightmost 0 in x minus 1, after we do an AND, that 1, the rightmost 1 in x, will become 0, because 1 ANDed with 0 is always 0. And so ANDing x with x minus 1 will delete the rightmost 1 in x. Now we can use this fact to modify our bitcount function. So now instead of every time shifting x over by 1 to the right, what we can do is instead do this AND operation. Now I'm going to use the assignment operator. And we no longer have to check if, we have a 1 at the end or a 0. We can just increment b, because every time we're just going to be deleting the rightmost 1. We are just deleting ones. There is no more need to shift anything. And that should be okay. So let us just compile this and run it. And the number of 1s in 190 is 6. And you can verify that if you want, but yeah, it's true. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.